In this video we will practice graphing trig functions. Starting with sine of x, which we basically have memorized at this point. The first thing we memorized was that the period is 2 pi for your basic sine function, and I like to put the period right here in my graph. And if that's 2 pi, then that means right here halfway is going to be 1 pi, and half of that is going to be pi over 2. And then this is 3 of these, so this will be 3 pi over 2. Okay, so we know that the sine function starts off at 0, or wherever the midline is. And we've memorized that the midline of the sine function is the line y equals 0. Okay, basically the x-axis. And the amplitude of a sine function is 1. That means from the midline it goes up 1 and then down 1. So it's going to follow this pattern. It's going to go up 1 and then back to the midline, and then it's going to go down 1. Maybe I should use a different color. So it starts from 0, it goes up 1, back to the midline, down 1, and back to the midline. And of course we could continue that pattern in both directions if I went down again and back to the midline, up again and back to the midline. Okay, so the graph should be looking like this. Alright, something like that. The domain is going to be negative infinity to positive infinity, really for all of these trig functions. Well, for sine and cosine anyway. They go left forever and right forever. The range in this case is from, and we really should label this because this was -1 and +1. So from bottom to top, the range is going from -1 to +1. Okay, there was no phase shift on this. Alright, and we'll see what a phase shift looks like later, but in a nutshell, something would be added on, or subtracted. There'd be something like this. Anyway, that's it for A. Let's go on to take a look at B. Well, cosine is another simple one. Again, just like sine, the cosine has a period of 2 pi. So I'm going to label it in the same way. Okay, so the period is 2 pi. We've memorized that the midline is the x-axis, so that's y equals 0. The amplitude, just like for the sine function, is 1. I can tell once again there's no phase shift. Okay, but here's where it's different. And let's see, this is 1, this is -1. The cosine function does not start off at the midline. Alright, it starts off up at the amplitude, at its high point. And then it goes, drops down to the midline, and then goes below, and then back to the midline and above. So that's your basic cosine pattern that we have memorized. And we could continue that pattern by going back down to the midline and below. Back down to the midline and below. Okay, so this function is going to look like this. Alright, and again the domain is negative infinity to positive infinity, and again the range is from -1 to +1. Alright, the domain is this because it goes left forever and right forever. The range is because it, from bottom to top, it reaches a low of -1 and a high of +1 with no breaks in between. So that's B. Okay, for part C we've got cosine, but we have some changes here. Now this, when you have a number in front of the variable like this is a B value. Okay, that's a B. That's going to come up right now because the period is going to be given by this little formula. It's always 2 pi divided by that B value. So in this case, that means the period is going to be 2 pi divided by 4. Okay, now that's going to cancel, and that's going to mean that the period is pi over 2, because 2 goes into 4 twice. Alright, so that's new. So I'm going to put pi over 2 right here, because that's the period. Now if I take half of pi over 2, that's going to be pi over 4. So that goes here. If I do half of pi over 4, that would be pi over 8. And this is 3 of these. So this will be 3 pi over 8. Okay, now I'm going to treat this as 1, 2, 3, and -1, -2, -3. Now, this -2 on the end is a translation down 2. That means we're going to have a new midline. Instead of the midline being the x-axis, the midline is going to be down 2. Okay, so here's my midline. So let's write this down. So we have a period of pi over 2. The midline is y equals -2. The amplitude, the amplitude is going to be given by whatever number is in this position. But there's no visible number, so that means the amplitude is still 1. By the way, the amplitude is always positive. There is no phase shift still. Okay, if this were in parentheses, then I'd have a phase shift of 2 to the right. But without parentheses, then it's like this is a vertical translation. So let's start graphing. The cosine function does not start at the midline. It starts at the amplitude. So the amplitude is still 1. So I'm going to go 1 above the midline. And then the cosine pattern is that it goes down from there back to the midline, and then it goes the amplitude below, and then back to the midline, and then back to the start again. And then it repeats that over again. So it will go back to the midline again and down, and then I'm out of space. And to the left, it will go down to the midline and below. So this is what our graph should look like. I just need to connect the dots. So your graph should look something like that. Once again, because it goes left forever and right forever, the domain is -infinity to +infinity. Now the range, the low is at -3, and the high is at -1. So that's going to be the range. Alright, let's look at function d. Alright, now the b value is the number that's right here. The b value is 1. The reason why I need that is to find the period, which is what I always do first. And the period is 2 pi divided by that b value. So that means the period is going to be 2 pi. Well, it's just going to be 2 pi. Since the b value is 1. So we can write that down right here. So the period is 2 pi. And we can also record that on our graph. So this will be 2 pi. And so that makes this pi. And this will be pi over 2. And this will be 3 pi over 2. Okay, what else? A number in this position tells us the amplitude. So the amplitude is 3. The amplitude is always positive. So even if this had been a negative 3, the amplitude would still be positive 3. What about the midline? Well, the midline is if something is, it's normally 0, the x-axis, y equals 0. It changes if something is added or subtracted to the end. Like, for example, if there was a plus 1 here. But when there's nothing being added or subtracted on the very end, then the midline stays y equals 0. So that's what's happening right now. Y equals 0. What about a phase shift? This graph does have a phase shift. Alright, when you have the parentheses like this, and you have x minus something or plus something, this number right here tells you the phase shift, except for it's in the opposite direction from the way it looks. It's like the way we normally talk about a left or right shift, and it's the opposite, so this would be a shift to the right by pi over 4. Alright, but in the context of graphing trig functions, we call that a phase shift. So it's going to be a phase shift of pi over 4 to the right. Okay, notice we use the opposite sign. If this had been a plus pi over 4, then here I would have put negative pi over 4. Alright, but if you put the word in there to the right, that sort of covers it as well. Anyway, I think we're ready to start graphing now. So we are dealing with the sine function. Wait, the midline. Oh yeah, it's y equals 0. The sine function starts at the midline. Now actually, let me switch over to my skeleton color. We are not going to do the phase shift yet. So for the moment, I'm going to ignore this. And I'm just going to do 3 sine x. That's all. So I'm just graphing the skeleton for right now. So my skeleton will start at 0, and then it will go up the amplitude. So it's going to go up 3, and then back to the midline, and then down 3, and back to the midline. Alright, so that is going to be my skeleton. I could continue this pattern of my skeleton by going up 3 and back to the midline again, and on the left I would go down 3 and back to the midline. So this is my skeleton. Now for the real graph, however, I have to use the phase shift, which is to the right by pi over 4. Okay, so look, this is pi over 2 right here. So this would be pi over 4. So that's important because the scale changes from problem to problem. But on this problem, pi over 4 is 1 square. So everything needs to move 1 square, pi over 4, to the right. So in this case, this dot would move here, and this one goes here, and here, and here, and everything moves to the right. Now this one's like off the grid, so I'm not going to worry about it. This one's going to move here, that one's going to move here. Okay, so these pink dots are the real graph. So those are the only ones that I will connect. So it's going to look something like this. Okay, and that's as much as will fit. So let's see, did I fill in everything? I guess now I just need the domain and range. The domain again is going to be negative infinity to positive infinity. The range from bottom to top, it goes from negative 3 to positive 3. It's really bothering me that it's not quite hitting this dot. OCD! Alright, so that was D. Are there any more of these? We've done 4. That seems like plenty. Oh, wait, there's more. Fantastic. So let's see, what do we have here? Well, we have our B value, which we are going to need. Because the period is 2 pi over b. That's why the period is going to be 2 pi over 2. Those 2's cancel out, so that means in this case the period is going to be pi. That's why I'm going to put pi right here. And then so halfway would be pi over 2. Half of that would be pi over 4. And then right here would be 3 of these, so that'll be 3 pi over 4. Alright, so find the period is pi. What about the midline? Well, this number right here tells us that there's a vertical shift of 4. So that means the midline is going to be y equals 4. We should go ahead and graph that. So the midline is going to be way up here. Alright, so there's your midline. Okay, what about the amplitude? Well, the amplitude, we look right here. There's nothing there, so it's a 1. So that means the amplitude is still 1. Alright, what about a phase shift? This one does have a phase shift. Alright, that is not an eraser, or is it? For the phase shift, we look right here. Now, as is, this is not the phase shift because of this 2. For this number to be the phase shift, we need to factor out the 2. So in other words, we need to bring the 2 outside of the parentheses first. Now, when you're factoring out a number, to find out what goes on the inside, you have to divide. So if I take this number I'm factoring out and divide with it, that tells me what goes on the inside. So here these 2's cancel out, and so I will just have x. But now I can see that my phase shift is going to come from this pi over 2. Okay, but it's the opposite of what you normally think. So this is actually going to be a shift to the left pi over 2. And to represent that, I'm going to put a negative on it. So I'm going to put negative pi over 2. And just to be extra clear, I'm going to write left. Okay, when there is a phase shift, I start by making a skeleton graph. I do not connect the dots yet. So my skeleton graph will not include the phase shift. This is the sine function. So the sine function starts at the midline and then it goes up, unless there's a reflection, which would be a negative number in the front. But we haven't seen that yet today. So the sine function will start at the midline and go up, and then back to the midline, and then down. Alright, I'm using the amplitude of 1, notice, and then I go back to the midline. So this is one period of the sine function, showing everything except for the phase shift. I'm going to go ahead and continue this pattern by going up and then back to the midline. On the left I would go down and back to the midline. Now remember, the phase shift tells us that we have to go pi over 2 to the left. Now look where pi over 2 is. This is pi over 2. Look how many squares that is. Alright, on this scale, pi over 2 is 4 squares. So I need to move everything 4 squares to the left. 4 squares to the left. So that means, for example, well, first of all, these two dots, there's no space to move them. But this dot right here is going to move 4 squares to the left and end up right here. This dot right here is going to move 4 squares to the left and end up here. Now I don't need to keep moving these one at a time. Once I have one dot, really, I can just follow the pattern of the sine function, which I know it goes up and then back to the midline, and down the amplitude, back to the midline, up, back to the midline, down, back to the midline. But if you look at any of the skeleton points, you can see that yes, indeed, if I moved 4 to the left, it would land on one of my new points. So all I need to do is connect the dots of my pink graph, because that's the real graph. So in the end, your graph should look a lot like this. Alright, the domain, of course, is negative infinity to positive infinity, because it goes left and right forever. The range, let's look closely, from bottom to top, it has a low of 3 and a high of 5. So the range is 3 to 5. Okay, we have a lot going on for function f. Let's see, so this is the b value. That's right here, the b value. So we need that for the period, because the period is 2 pi divided by the b value. Okay, another way to write this is instead of having 2 pi over 1/2, that's the same thing as 2 pi divided by 1/2, right? Now, the way you divide by a fraction is you multiply by the reciprocal. So 2 pi divided by 1/2 is the same thing as 2 pi times 2. So that's why the period is going to be 4 pi. Okay, that is why I'm going to put 4 pi right here. Then halfway will be 2 pi. Half of that will be 1 pi. And then this position is 3 of these, so that'll be 3 pi. And might as well write down that the period is 4 pi. What about the midline? Well, you see I have a vertical shift down 1 because of this -1. So that's going to tell me that the midline is going to be y equals -1. Okay, how about the amplitude? Alright, this number tells us the amplitude. Remember that the amplitude is always positive. But so the amplitude is going to be 3. What about the phase shift? Yeah, there's definitely a phase shift on this one. Alright, it's time to find the phase shift, which has something to do with this, but it's not going to be pi over 2 because of the 1/2 is there. If the 1/2 was not here, then the phase shift would be negative pi over 2, always the opposite. But we need to factor out the 1/2 to figure out what the phase shift really is. Now, when you factor out 1/2, to figure out what goes on the inside, you need to divide. So I need to divide everything by 1/2. Alright, and that's going to tell me what to put on the inside. Now these 1/2s are going to cancel each other out and just leave x. But right here, look at this very carefully. What I have is pi over 2 divided by 1/2, right? I hope you understand that to divide by a fraction, you multiply by the reciprocal. So this is the same as pi over 2 times 2. Well, in this form, I hope you can see that these 2's will cancel out. And that's just going to leave pi. So this would be like x plus pi. That's where the phase shift comes in. Negative pi, always the opposite. Okay, so negative pi is my phase shift. So I'm going to go ahead and graph this now. I'm going to graph everything except for the phase shift. Alright, because there is a phase shift, I'm going to start with a skeleton graph which does not include the phase shift. Now remember that the midline is at -1. Alright, so you see the dotted line. And the amplitude is 3, so I'm going to be going up 3 and down 3 from the midline. So I just need to remember which function this is. So this is cosine. So cosine is going to start off at the amplitude away from the midline. So I'm going to start off 3 above the midline for cosine. And then follow the cosine pattern, which is you fall back to the midline, and then you go the amplitude below the midline. Okay, so I have to go 3 below, and then back to the midline, and then 3 above. Alright, so this is one period of this skeleton cosine function. I could continue by going back to the midline, and 3 below again, and over here I'd go back to the midline, and 3 below again. So that's a complete skeleton till I ran out of graph. Now, do not connect the skeleton because we haven't done the phase shift yet. Remember that the phase shift is negative pi. Okay, well that's too big. Remember that is pi to the left. So it's important before you start moving things around that you look and see how big is that at this scale. So look, here's pi right here. So notice that pi is 2 squares on this grid. So I need to move each of these points 2 squares to the left. Alright, there's no room to move this point, but I can move this point 2 squares to the left, and I can move this point, and I can move this point, and 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 this point. Okay? And so these pink dots show me where the real function is going to be. Alright, so this is what I have. And there's space for me to put one more over here because just following the pattern, midline, down, it's going to go back to the midline again. So I could just finish this off like so. Alright, so that is what your graph should look like. Of course, the domain is negative infinity to positive infinity because of the way it goes left forever and right forever. The range is slightly more interesting. bottom to top, it has a low of -4 and a high of 2.